as far as we are concerned with this discussion here, the lift-induced drag is going to be more, and the aircraft is heavier and slower. Got the reason why? Because heavier the aircraft, more lift required, the lift-induced drag increases, because it's that same lift is the one that is inducing the drag. And then the slower the aircraft, the wingtip vortices get more time to kind of complete the circulation, and therefore, again, you have stronger lift-induced drag. So what can you say about the relationship? We will crash now, we can come back when we crash. Think about the relationship between lift-induced drag and speed. Alright, yes. So we saw two different factors, Anuj here, which the lift-induced drag is dependent upon. It depends upon the lift force, it depends upon the speed. Now look at something which we discussed yesterday, because since Saran was not there, I'm just saying this once again. Let's look at the dependency of the parasitic drag. The parasitic drag coefficient I will put as CDP, and this the induced drag coefficient is CDI. Right, let me make it a different color. Alright, yes, now if I draw a graph between this coefficient of drag with speed, remember, as I've told you yesterday, whenever I see a graph with speed on the x-axis, it's more like the actual flight data. It's not from the wind tunnel testing or something. Yes, Anuj, tell me how this graph would be between the parasitic drag and the speed. What is going to be the value of parasitic drag at lower speeds?
Drag will be more, sir. It will be more higher.
At lower speeds, when the speed is lower, what is the sorry, this one? Yeah, when the speed is lower, what will be the parasitic drag? Just like whenever you think about parasitic drag, think about the umbrella. Is it going to affect you more at lower speeds or higher speeds?
No, higher speed.
Higher speeds. When speed is higher, you have a higher parasitic drag. Speed is zero, parasitic drag is zero, and since it is proportional to square of velocity, drag proportional to square of velocity, it's not going to be a linear variation, rather it's going to be a exponential variation, like this, all the way. This is the graph between parasitic drag versus speed. What about lift-induced drag? Yes, Dipanshu. We just saw the lift-induced drag with speed variation. Lower speeds? High lift-induced drag. Yes, that's because lower the speed, more the time. So as the speed increases, what happens? The parasitic drag starts. The lift-induced drag starts reducing. Yes, the lift-induced drag reduces because now the air gets lesser time to kind of complete the circulation. Now think about one more thing. What happens when the aircraft comes very, very close to ground? So you come for landing, this is your landing attitude, you come down, just before touchdown you enter into a kind of a landing attitude called as flare. It's more like a stalling attitude, and you've just touched down. You must have seen aircraft touching down. Depending upon the aerodynamic property of the aircraft, you might have to pitch up more or less, but basically this is the flare attitude. Now what happens when you come closer to the ground? So you're coming for landing, you are slower, you're heavier, you have very strong vortex. When you come very, very close to ground, the ground is right here. Now the air is not able to complete the circulation because the ground kind of breaks it. Yes. So what happens to the effective lift? All of a sudden the lift-induced drag disappears, and therefore the aircraft is going to experience a beautiful, nice and smooth additional lift, which is now going to prevent you from landing, because now you have lift and you will kind of float over the runway. Because there is an extra lift, you have to somehow deplete that lift off if you want to touch down. Now what happens if you don't do anything about it? You have a long runway, you're kind of floating all the runway, reach the end of the runway. If you don't go around, you will touch down probably maybe after 3/4 of the runway, and then you won't have enough space to stop the aircraft. That's the danger there. This effect is what is called as the ground effect. Very, very helpful, especially for taking off from short fields, very, very short aerodromes. What you do is you use the ground effect, you take off, you accelerate, and then you climb out. So all those things you will see when you fly. I'll talk about that when we talk about landing roles and stuff. But that is what is called as ground effect. In ground effect, what happens is the lift-induced drag reduces because the wingtip is not able to complete the circulation because of the ground. I told you about the pelicans that kind of glide on top of water for long distances before it touches down. They use the ground effect because this leaking of air happens around their wings also. That is the model for aircraft, right? So that does not happen when it is very close to water, and therefore they experience a very cushioning, the cushion effect because of the lift, and they use that. They glide a longer distance, gives them rest to the wings, and they touch down. Yes, and I think I've told you about the Caspian Sea Monster or Plan, if you remember. A big aircraft that uses ground effect to just fly on top of water. It was used in the World War times. But these are the two different graphs. One showcasing the effective parasitic drag with speed, other is the lift-induced drag. What are we looking at? We're looking at the total drag system here. How can we find the total drag? Look at a total drag here at the midpoint. So what is the whole idea? We are trying to minimize the drag. And why do we have to minimize the drag?
So that we can fly smoothly with the equal amount of lift as compared to drag. When we get a speed of VMP.
So what is the advantage of flying at a minimum drag speed?
The minimum drag speed.
You need to use less power basically.
Less power.
Less thrust, that's fine. You use less thrust.
More range.
More range, yes. Maximum range and less thrust. Less thrust means because thrust is the one that is balancing drag. Minimum drag, minimum thrust, less money. So economically that is more viable. And second reason is what you said, minimum drag speed will give you maximum range. Maximum distance for a given amount of fuel. Yes, and where does it happen? Minimum drag happens when both the parasitic drag and lift-induced drag are minimum. Not when they are individually at the minimum points. It happens when both of them are minimum. And that happens at the intersection point. What is speed called as? VMD, minimum drag speed. Yes, and the value of the drag can be found out by interpolating it straight here all the way. Yes, now if you draw the total drag curve, we saw this in the last class yesterday. Total drag at say for this particular speed right here is you have so much of lift-induced drag, there's a small amount of parasitic drag, and that will give you the total drag point here. And similarly at higher speeds also you have a total drag point that is somewhere here. Minimum point will be double this value, which is here, and this is going to give you the total drag curve. Did you understand how I drew this term?
Yes.
We have done this now a month before.
Yeah.
Yesterday also I explained this. Yeah. Do you want me to explain this how we found this curve? Just adding these two.
Yes.
Right? So what can you see from this? Yeah, yes, go ahead.
No, I said yes.
Yeah, so what can you see from this total drag curve? At lower speeds and at higher speeds, you have a higher drag.
Yes.
Right? What happens at lower speeds? The drag is higher because of what? The drag is higher because of high lift-induced drag. At higher speeds, the drag is higher because of high parasitic drag. But in either ways, you're going to get a higher drag. This is a total drag curve. Now, the minimum point of this is what is the minimum drag. And the speed corresponding to that is what is called as the minimum drag speed. Now tell me, what are the advantages of flying at minimum drag speed, one by one? Yes, Dipanshu, the first one, advantage of flying at minimum drag speed.
So the best thing that you will get the maximum range.
That's right. So maximum range. Yes, Anuj, another advantage of flying at minimum drag speed. So flying at minimum drag means what is drag? How is drag countered? How is drag opposed? That's right, Sharon. Yes. How is drag opposed? Using thrust. So minimum drag means minimum thrust. Remember the very first class of technical, we looked at the work equation, work is equal to force and displacement, and we kind of kept the work constant, and we saw how this works. Right? Minimum drag is minimum thrust, and minimum thrust is minimum fuel. Minimum power basically, therefore power is basically RPM, number of times it rotates, therefore it's minimum fuel, and minimum fuel means it's more economical, right? Less money, right? So minimum speed is, flying at minimum drag speed is economical. Now, this is the total drag the aircraft is going to experience. So how can I counter this drag? Do not think about lift when you talk about drag. More, if you have a drag, we are applying. You have engines, fuel. We make the engine do work power. We produce thrust. So ultimately, why are we producing the thrust to counter this guy here? the parasitic and lift-induced drag which you're going to experience, right? So when you look at this curve, it's a total drag curve. So you can also write this as a total thrust curve, because drag is balanced by thrust. So if you have so much of drag, you need so much of thrust. But what thrust is this? This is a thrust.
Required.
Thrust required, yes. That is what you want to understand. It is a thrust required. This is the thrust required curve. So the drag curve and the thrust required curve looks the same. It's not exactly the same, but it looks the same.
Basically the speed required, right?
Say again?
The speed required.
No, thrust required.
Okay.
Okay, what curve is this?
That is the total drag.
Do you understand that part? Because the sum of these two curves.
Yes, yes.
Yeah, so what is this total drag? How are you going to deal with this total drag?
By giving thrust.
Yeah, so your thrust also has to follow the same fashion. At lower speeds, you need higher thrust to counter the higher drag. At higher speeds, you need higher thrust to counter the higher parasitic drag. At minimum VMD speeds, you need minimum thrust because you have only minimum drag. So basically, if I plot the thrust curve, required curve, that curve also will be having the same shape.
Okay.
Right? So this is nothing but a thrust required curve. So basically for the exams, they can give you a graph like this and a curve like this. And they'll probably nothing, there's nothing in the y-axis, and probably they'll ask you to find out which of the curve represents. They'll give you, this is the curve between lift coefficient and angle of attack, or lift bar drag ratio and angle of attack, power required curve, thrust required curve, or drag curve. So you have to pick up what we have to know the shape here. So this could be a drag curve, this could be also a thrust required curve. Remember the word here, required. As I told you yesterday, if I want to lift this particular pen up, I need some amount of energy. That's the energy required to lift the pen. But there is something else called as the energy available. So can you differentiate between the energy required and energy available with me? I don't have to use the entire energy available with me to lift this pen. Right? But basically, practically, I should have the energy required should be less than the energy available. That is the reason why I cannot lift an elephant, because the energy required is much more than the energy available with me. So in flight, thrust required is there, the thrust available from the engine is a different thing. And ideally, practically, the thrust required has to be less than the thrust available. Does it make sense?
Yes.
Yeah. So we'll talk about thrust curve again a bit later, but yeah, this is the thing. So two different factors affecting lift-induced drag. What's the first one? It's the lift force. Higher the lift force, the higher the weight, more lift-induced drag. Speed, lower the speed, more lift-induced drag. Right? The third factor affecting, affecting the lift-induced drag. Let's see that. Did you all understand this?
Name of the factor is pressure difference or lift force.
Yeah, pressure difference, which is the lift force, right? Pressure difference is the one that produces the lift force.